Something unusual happened in China this week. A typhoon made landfall, weakened, and began moving inland. And you might expect that to be the moment the danger starts fading. Instead, the rain kept coming. In Shanghai, one weather station recorded nearly 400 millimeters of rain in just 24 hours. The highest 24-hour total recorded at that station in more than 150 years. More than 1 million people were evacuated across eastern China as authorities prepared for flooding and landslides. Shanghai was hit by enormous disruption, with flights canceled and transportation systems affected as the rain intensified. And now, even after Typhoon Dolphin weakened, its remnants are still helping produce torrential rainfall farther inland. Today, parts of Beijing are dealing with intense rainfall and flooding. Bus routes have been halted, tourist sites have closed, and subway services have been disrupted. So here's the question. How can a storm become weaker on paper while the flooding threat is still getting worse? Because the most dangerous part of this event may not be the wind. It may be the water. And to understand why, we need to look at what Typhoon Dolphin left behind. Typhoon Dolphin made landfall in China's Zhejiang province on August 9th. At landfall, it was still packing winds around 150 kilometers per hour. That alone would have been enough to create a serious threat along the coast. But the storm's impact quickly became much larger than a simple landfall story. Across eastern China, authorities moved more than 1 million people away from areas considered vulnerable. Wenzhou alone relocated more than 900,000 people, while hundreds of thousands more were moved elsewhere, including Shanghai. Shanghai also saw enormous disruption. More than 1,300 flights were canceled, and transport systems were heavily affected as the rain intensified. But here's where the story gets interesting. Dolphin was weakening. A tropical cyclone loses its energy source when it moves over land. It no longer has the same access to the warm ocean that helped power it. Its winds weaken, its circulation becomes less organized, and eventually the storm loses its identity as a typhoon. So why wasn't the threat disappearing with it? Because a weakening tropical cyclone can still carry something enormous: moisture. Think of the storm as a giant atmospheric transport system. It takes warm, humid air from the ocean and pushes that moisture into a much larger weather pattern. And when the circulation moves inland, the moisture doesn't simply disappear. It has to go somewhere. Imagine the atmosphere as a giant sponge. Warm air can hold more water vapor than cold air. A tropical cyclone can load that atmospheric sponge with enormous quantities of moisture. Then the storm moves. The circulation begins to weaken, but the moisture can continue being transported hundreds of kilometers away from the original center. That's part of what we're seeing now. Dolphin's remnants have continued feeding rainfall farther inland, with heavy rain affecting a huge area of China. And this is why simply looking at the storm's wind speed can be misleading. A weaker storm does not automatically mean weaker rainfall. Sometimes the most important question isn't how strong is the storm, it's where is all that moisture going? And right now, some of it is moving directly into regions that were already vulnerable to flooding. There's another piece of this puzzle. Rainfall isn't determined only by how much moisture exists in the atmosphere. It also depends on how efficiently the atmosphere can force that moisture back out. When warm, humid air rises, it cools, water vapor condenses, clouds grow, rain develops. But if the atmospheric circulation keeps feeding more humid air into the same region, the process can repeat again and again. It's almost like leaving a faucet running over the same drain. The problem isn't one burst of water, it's the fact that the supply keeps arriving. And when rainfall falls faster than rivers, drainage systems and soil can absorb or carry it away, the water begins accumulating. First on streets, then in low-lying areas, then in streams and rivers. And eventually, the entire landscape can start behaving like a giant drainage system under pressure. That's why a rainfall event can become much more dangerous than the storm that originally caused it. Now look at what happened in Shanghai. One station recorded nearly 400 millimeters of rainfall in 24 hours. That's an extraordinary amount of water. And the important detail isn't simply the number, it's the record behind it. That station's 24-hour rainfall total was the highest in more than 150 years of records. That doesn't mean every part of Shanghai received 400 millimeters. It doesn't mean China as a whole experienced a single 150-year rainfall event. And it certainly doesn't mean that every part of the country was under the same conditions. But it tells us something important. Some locations were experiencing rainfall far outside their normal historical range. And when extreme rain falls on a city of millions, the consequences aren't abstract. Water begins collecting on roads. Vehicles become stranded. Public transportation slows or stops. Airports cancel flights. Emergency workers have to move through flooded streets. And the city has to keep functioning while enormous amounts of water are arriving from above. This is where the story becomes much more than weather. A modern city is essentially a giant machine designed to move water away. Roofs collect it, gutters collect it, drains collect it, pumps move it, rivers carry it away, reservoirs store it. Everything works, because the amount of water arriving stays within a manageable range. But extreme rainfall changes the equation. If water arrives faster than the drainage system can move it, the system doesn't simply become less efficient. It starts losing the battle. And that's when you get the images that have been coming out of China. Roads covered in water, vehicles struggling through flooded streets, transport networks disrupted, and people trying to move through conditions that were completely different only hours earlier. The same thing is now happening farther north. Today, Beijing has been dealing with torrential rain linked to dolphins' remnants. Reuters reports that the city issued a high-level rainstorm warning, halted 250 bus routes, closed 150 tourist sites, and reduced subway speeds on 10 lines. One district recorded 90.7 millimeters in just 1 hour. Think about that number. Not an entire day, not an entire storm, 1 hour. This is one of the strangest parts of the story. The original storm track and the rainfall footprint are not necessarily the same thing. The center of the tropical cyclone can move away, but the moisture it transported can continue interacting with other weather systems and the broader atmospheric circulation. That's why the map of danger can keep expanding even after the storm itself begins weakening. And right now, that's exactly what authorities are watching. Heavy rainfall has spread across multiple provinces, including areas far from the original landfall. Rainfall records have also been broken in parts of Henan and Hubei, where some locations received more than 200 millimeters in a day. So the question isn't simply, where is Dolphin? The better question is, where is the moisture going next? And there's another variable that can turn heavy rain into something much worse, the ground itself. When humid air encounters terrain, it can be forced upward. As that air rises, it cools. Clouds can develop more efficiently. Rainfall can intensify. And in mountainous or hilly regions, that can create another danger, rapid runoff. Water that falls onto a steep landscape doesn't necessarily stay there. It races downhill. It fills streams. It can push rivers higher. And when the ground is already saturated, there is less capacity for additional rainfall to soak into the soil. That is when flooding can accelerate extremely quickly. And that's also why authorities have been warning not just about urban flooding, but about landslides and other secondary hazards. The storm may be weakening, but the landscape can still be responding to everything that has already fallen. There's a tendency to watch a typhoon like a countdown. The storm approaches. It makes landfall. The eye moves inland. The wind decreases. The storm is downgraded, and people assume it's over. But that is not necessarily how the most dangerous rainfall events work. The wind is only one measurement. Pressure is another. Rainfall is another. Storm surge is another. Moisture transport is another. River levels are another. And soil saturation is another. A storm can become weaker while one of those other hazards becomes more important. That's why the aftermath can sometimes be more complicated than the landfall itself. The center of Dolphin may no longer look like the monster satellite image that dominated the news a few days ago. But the water it helped move across the atmosphere doesn't care what category the storm currently has. Now, there is an important distinction. This does not mean China is facing some unprecedented nationwide catastrophe. It does not mean every city will flood. And it does not mean every rainfall record in the country is connected to exactly the same mechanism. The facts are more specific, and honestly, they're more interesting. A powerful typhoon made landfall. More than 1 million people were evacuated across eastern China. Shanghai experienced an exceptional rainfall event, including a station record spanning more than 150 years. The storm weakened, but its remnants continued producing heavy rainfall farther inland, and today, Beijing and other regions are still dealing with significant rain and disruption. That's already a serious story. We don't need to exaggerate it. So what should we watch now? Not simply the position of Typhoon Dolphin. Watch the rainfall bands. Watch where the heaviest moisture is moving. Watch river levels. Watch areas where the ground is already saturated. Watch mountain regions where intense rainfall can trigger rapid runoff and landslides. And watch how quickly transportation systems recover. Because the storm's name disappearing from the weather map doesn't mean the consequences disappear at the same time. The rainfall has already changed the conditions on the ground. And every additional burst of heavy rain is being added to that existing problem. The storm may be weakening, but the environment it left behind is still reacting. There is an almost misleading image that appears whenever a typhoon weakens. The satellite picture gets less impressive. The spiral disappears. The winds decrease. The storm is downgraded. And it looks as though the danger is fading. But Typhoon Dolphin is a reminder that weather disasters don't always end when the storm does. Sometimes the most important thing a storm leaves behind is invisible: water vapor. A massive amount of it. And once that moisture begins falling over cities, mountains, and river basins, the problem changes completely. Shanghai has already recorded a 24-hour rainfall total at one station that surpassed anything seen there in more than 150 years. More than 1 million people were evacuated across eastern China. And today, the remnants of Dolphin are still producing torrential rain farther inland, with Beijing among the places facing major disruption. The typhoon may be weakening, but the atmosphere hasn't finished delivering its water, and that is the part of this story worth watching next. Because the most dangerous moment isn't always when the storm is strongest. Sometimes it's when you think the storm is already over,